Yeah, if you're expecting Raoul Pal, sorry, you got me. Raoul's flight got cancelled. Well done for getting here. It was a bit of a mission for me, but I'm very grateful to be able to come here and speak to you. Yes, if you don't know, yeah, my name's Gavin. I've been in this industry about 10.5 years, more or less. And I'm reasonably well known as the co-founder of Ethereum and founder of Polkadot. Jam. Jam is what I've come here to tell you a bit about. I'm not going to go too deep into the technicals. I know that, maybe, actually, I'm kind of wondering, can I get a show of hands for people that have written like a line of code and compiled a program knowingly? Okay, so maybe a half to a two-thirds. And hands up if you know of the yellow paper, the Ethereum yellow paper. Okay, like maybe a third. So it turns out that a yellow paper, which I wrote the first version of, it was first published almost exactly 10 years ago to this day. It was actually 10 years ago on Tuesday. Today's Thursday, but very close. And one of the things that I really want to get across is that I've been working on something very similar in direction to the yellow paper, but I think a little bit more technologically advanced. But I'm going to get to that in a second. For now, Jam. So Jam is a roll-up reactor, right? Basically, it's a new design of blockchain that is very much designed around bringing roll-ups together, hosting roll-ups, and then combining them in a succinct model, in a really effective model. So it's got secure, audited roll-ups. These are a kind of roll-up that we've developed. We developed them for Polkadot, but in reality, they're very much like other roll-ups, if you've heard of roll-ups. Basically, a way of getting through a lot more data and a lot more computation without bogging down everyone that's running through the main blockchain. It comes with high resilience data availability, quite a lot of it, and we've developed a new virtual machine. So if you're familiar with the EVM, we've developed a new virtual machine called PVM. Now, Polkadot was originally, is based around WebAssembly, a protocol that's, a machine spec that's quite made for like the web browser. We've kind of thrown that out and started afresh, basing it actually on the RISC-V architecture, which has gotten a bit of fame recently with some of the other projects that have also been using RISC-V. And PVM is basically a sort of alteration of RISC-V that makes it inherently very recompilable to x86 code. We've also managed to get metering in there, which is really helpful if you're trying to do anything in consensus. And because it's RISC-V, a RISC-V derivative, it's very easy. There's already a lot of tooling, right? LLVM already works with RISC-V, and it brings with it, I don't know, dozens of languages that you can target at now PVM. Now, the key thing to understand about Jam is it's transactionless. It doesn't have any transactions that make their way directly onto the Jam chain. Rather, it has this thing called agile core time. It's a concept that we've been pioneering, that's been pioneered in Polkadot. But basically, you buy chunks of blockchain, of block space, if you like, at a time. Significant amounts of block space. I'll get onto the numbers in a second. So the Jam data topology looks a bit like this. It looks like a series of flowers, if you like. Each flower is like a slice in time or a block. Now, the interesting thing is that down the middle of the flower runs this kind of like the center of the flower, right? Like where all the petals lead into, right? The bit that the bees fly in and try and pollinate, whatever. This is like very similar to what normal blockchains are. They're basically like just a series of progressions of state, right? And normally the transactions go straight into the center. In fact, with Jam, the transactions go, or the data coming from the external world, goes via the petals. The petals represent the blockchain equivalent of supercomputers, right? They go very, very fast. They can process a lot of data. They can get through a lot of computation. Now, the cool thing is that the petals don't necessarily map one-to-one on each other, like in designs like Polkadot and some of the, for example, in Ethereum, some of the ZK, the roll-up proposals. Instead, the petals are just general stateless machines. They can do basically anything, and they can change what they're doing and the data that they're working on from time slice to time slice. So let's have a look at one of these cores. Pull one of the petals out and see what it looks like. So here is the anatomy of a Jam core, one of these petals. It's a bit of a misnomer because, of course, you expect the core to be the middle. Maybe there's a name change in the future of this, I'm not sure. But anyway, the core itself, so this petal can process really quite a lot of data. 2.5 megabytes in is what we're targeting, 2.5 megabytes out. It can take any data that's already been processed by other cores in the past, do stuff with it, and then leave it for further future cores to work with. It's got a limit to the past. It only stores a month worth of data is what we're targeting, and therefore, if you're leaving data for other times to process, then it will only be around for a month. Now, we can also send some information into the middle of the flower, right? Less because, of course, all of these petals can't send all of their information into the middle, or we'd have a scalability issue. They can send about 15 kilobytes a second into the middle, which can then integrate it with all of the other stuff that all the other petals have been doing, and fold it into the machine state, right? The single state machine. So we have this, what I call a semi-coherent model, right? It's not fully coherent like you would get if it's just a single state environment where everything can interact with everything else all of the time. But it's also not a persistently fragmented model like you would get if you just have different separate blockchains that are bridged with each other, or models like Polkadot and ZK rolled up Ethereum, where you've got totally different chains that maintain their own state and can occasionally kind of send messages into the middle. Our current performance targets that we're looking for Jam are 2 petabytes, a little over, for high resilience distributed availability, right? So that's the total amount of data that it's going to be able to basically store at any given time. And the amount of data per second, the amount of sort of input and output that it can do is 850 megabytes, and then it keeps that 850 megabytes around for 28 days. Now, in terms of in-core computation, estimations are really hard to make because the PVM architecture is totally different to the EVM architecture. It's much more in line with the x86 with real hardware architectures. But in our admittedly pretty crude estimations, we are conservatively, so at the lower end, estimating around 150 billion gas per second, right, across all of the cores. In terms of the coherence bandwidth, which is basically the data that makes it from the cores into the middle, that's about 5 megabytes a second, which gives, once you get it into the middle, you can do about 250 million EVM equivalent-ish gas per second. Now, these numbers are probably going to get updated as we do more tests to get real empirical results. But back of the envelope, these are the sorts of numbers that we're looking at. Now, the thing I really want to discuss today is the approach that we're taking with building out Jam. It's rather a different approach to how what we've done with Polkadot, and it's centered around the desire to really decentralize and create a decentralized protocol. It's very easy to fall into a sort of very centralized, even if your network is decentralized, even if you have lots of different validators all sort of validating, and not all networks do by a long shot, it's not always so easy to have a decentralized protocol, right? Decentralizing a protocol implies that expertise on the protocol is also decentralized, that it's not just contained within one group or one company. So in pursuit of this, there are a few initiatives that Jam is bringing. One of them is the gray paper. So the gray paper, in fact, here it is, the Jam gray paper. It can be seen as a follow-up in some regards to the yellow paper, in that it draws upon many of the concepts in the yellow paper. There is many references to the yellow paper, and it's in a similar format to the yellow paper with a similar desire to have a formal, pure mathematical specification of the protocol. Not one that's defined in terms of an implementation that comes with all of the opinionation about the implementer and all of the opinionation about the language that it's implemented in. No. This is a pure mathematical specification for the JAM protocol. It's taken me about 6 or 7 months to write it. It's not really finished. I expect for the coming months for the paper to evolve, much as after the yellow paper was initially published, April 16th, I think, 2014, the Ethereum protocol wasn't properly sort of finalized really until I think around December that year. So I expect a kind of fairly similar schedule for the grey paper. The point of having a formal specification is to underline the fact that JAM is a protocol. It's not a piece of software. It's very easy to accidentally to think you're designing a protocol, but accidentally create software, where the protocol is secondary to the software, where the protocol is really defined by what this piece of software does. And that's problematic because it means that you're going to have centralized expertise. And that's not what we want for a decentralized, it's not what we need, indeed, for a decentralized protocol. If you want to see more about the grey paper, go to greypaper.com. I'll be doing a series of tours around universities to basically describe and try and teach how to interpret the grey paper. I'm well aware that the grey paper is not the easiest thing to read. It's not exactly a light bedtime story, but it nonetheless it is comprehensible by people with a reasonable technical background, and I want to make sure that the teaching material is there if you want to learn exactly how this protocol works. I'll put the dates and places on the grey paper website if you are interested in coming to one of them. Now, in addition to the grey paper, which basically gives this definition of correctness, there is also the JAM Prize. Now, the JAM Prize it's a fund that is underwritten by the Web3 Foundation. And basically, it's there to try to incentivize a wide range of individuals and teams to implement the JAM protocol in whatever way they choose. Indeed, we want, ideally, as many different kinds of implementation as possible. Like we want many different languages to be implemented and probably many different levels of the protocol to be implemented. So basically, we have an idea of having 4 implementation tiers and 4 sets of implementation languages, and the prize would be distributed to individuals or teams that are able to implement the JAM protocol and pass the various conformance and performance tests to the tier that they, to some particular tier. So the sorts of things, although it's not finalized, the sorts of things we're thinking about are things like, hey, you're at the tier where you can synchronize the chain. You can't build blocks, and you can't keep up with the chain necessarily, but you can at least synchronize with it. Maybe there's a tier above that where you can not only synchronize with the chain, but you can also you can be a validator. You can contribute to the extension of the chain. And then above that, maybe there's a tier where you can actually synchronize and keep up and validate on the final Polkadot JAM chain. Details will be coming soon, probably over the course of the next month or so. One of the things that was difficult when developing Polkadot and the Polkadot protocol was understanding why some things were not going as fast as we expected them to, or were broken when a node individually appears to act correctly, but combination of nodes seem to act incorrectly or not as we would expect. The emergent effect, so to speak, becomes sometimes problematic. Analyzing that is very difficult. So one of the things that we are sort of rethinking in that regard is how we get around this period of optimization and trialing and testing. And in this, there's therefore an initiative that we're starting, the Jam Toaster, which is basically a full-scale replica of the final Jam network. 1,023 nodes, which is what the Jam network is designed to work with, each going at more or less full speed. Where you can introspect deeply in exactly what has happened in the network. We've got, high-quality logging, et cetera, et cetera, et cetera. And the idea is that any implementation team that gets beyond a certain level, where their implementation actually works, is welcome to utilize the Jam Toaster to help optimize and debug their implementation in the idea that the final Jam network goes as fast and optimally as possible. If you want some numbers, got about 16,500 AMD Threadripper cores in there, 16 gigs just in L2 cache, 32 terabytes of RAM, and a lot of storage and some pretty hefty networking infrastructure. All right, so how does Jam become a thing? Well, the first thing to note is that the title of the talk was a bit presumptuous. It's not a given that Jam is what Polkadot will become. It's merely, I think, a front runner in a proposition for Polkadot. So the first thing is to publish the grey paper, the specification of Jam, which has just been done, as it happens. The second thing is to ratify the general approach and the scope that the grey paper proposes. And this is something that should be happening more or less now. A governance proposal will be put forward by the Web3 Foundation, and I'll go into that proposal in the next slide. Once the ratification happens, then the Web3 Foundation will be in a place to activate the implementation prize, this grey paper prize. Probably several months of protocol optimization, parameterization, and evolution will happen, as I mentioned before. But hopefully, if Ethereum is anything to go by, then the end of the year should see a reasonably final protocol proposal, protocol spec of the Jam protocol. At that point, I'd expect to see a final ratification, then finalization of validator implementations, and a migration from the relay chain to the Jam chain. So we have at the moment the Polkadot relay chain. Perhaps in the future, if everything goes to plan, there will be a Polkadot Jam chain. So let's have a look at the governance proposal. For those of you that don't know, Polkadot is a pretty heavily decentralized network, in particular over how it is run and funded. We put a lot of effort into DAOifying the protocol. Indeed, I think it's essentially the biggest functioning DAO out there. The scope and direction of the Jam, as specified in the grey paper, describe a protocol which should replace the relay chain, right? So that's the first point of the proposal. And then basically the next 3 points are to bestow responsibility onto the Polkadot Fellowship, which is basically the technical minds behind the Polkadot protocol and implementations. And they would be responsible for ratifying the final Jam specification. They'd be responsible for the development of all of the tooling and various bits of software that are required to be able to turn the Polkadot relay chain into the Polkadot Jam chain. And they would be responsible for determining when it's ready to go. And then at that point, halting the relay chain, starting the Jam chain with everything migrated over from the relay chain to the Jam chain. And finally, the readiness, so these guys, the Polkadot Fellowship, should not consider it ready until there is a successful independent audit of the protocol itself and 3 implementations that are viable, that can keep up with the network and produce blocks correctly, that are themselves audited. This approach is quite a lot different to the approach we have for Polkadot, which was get it out as fast as possible. With Jam, we really want to take the time and build and prepare to ensure that when it starts, it is resilient, it is decentralized. Good. I've said everything I've come here to say. I was actually given a 20-minute slot, and they kind of gave me half an hour, so I'm a little bit early, but do feel free to use the time to get a cup of tea. Thank you.